Alright, welcome back. It's time to dive into classification for class of service. So I'm going to, I think, keep this same topology for now. I'm tempted to change it for no other reason than to just not distract myself anymore. So you know what? I actually am going to do that. So let's go and cut this down to 3 routers, just so I'm not distracted by this PIM topology that I was working on before. I actually gave that an unplanned 3rd video, something I really can't afford to do. I need to get into practicing for the exam by next weekend. And I'm only going to have 2 weekends to do that, so that's going to be really important. So yeah, let's go ahead and blank out all the configs as well, and then we'll do a help apropos and learn about the 2 different kinds of classification, BA and MF. Okay, so let's do a help apropos on router 1. Okay, so it looks like we've got 2 results here. Okay, so let's look for MF. All right, and BA. Okay, so yeah, BA is we're gonna match on loopback. So let's do a pipe exclude except LOO. Oh. And then let's do except up as well, so we get rid of backup. Okay, so now we've got a lot of. Oh, you know what? I could just filter it out on class of service. That might be better. Yeah, I think that's going to be better. Let's do that. Okay, that looks good to me. Okay, so that's a good place to start. Let's pick out one that looks the best. So let's pick out one for MF and one for... Well, actually, let's start here at the Firewall Examples. Okay, so basic. So here we go. AF stands for. So actually, we're gonna be having a lookout for BA and MF. So the acronym A and F standing for Assured Forwarding is neither of those acronyms. MF nor BA. So I'm not sure what, so here's expedited forwarding traffic, and here's assured forwarding traffic. So we've got expedited forwarding policer, then we're going to set the loss priority, all that sort of stuff. Now we've got a assured forwarding policer, and I guess we're going to do different things. Oh yeah, so we're gonna throw it out, but here we're just going to set the loss priority. And this is the sort of thing I have a lot of hands-on experience with. If somebody needs to change their speed, this is the policy that it get changed. But of course, the amount of speed that can be delivered is dependent on the uplink. So I have a lot of experience with that. It's not just dependent on the uplink, it's dependent on the whole network, but usually you're fine if you make it across that uplink. And you just gotta trust that your network architecture is good, which it will be if you're working at a major company like that. Okay, so this looks good to me. It all looks familiar. Let's grab another one. So let's grab something that matches MF. Okay, so complex MF filter, that looks good. Okay, so this looks like it's more related to VoIP, so I don't think it's going to be a good one to look at more carefully. So let's look at MF destination. Here we go. So classifying packets based on their destination address. Configure an MF classifier that ensures that all IPv4 packets destined for the particular network in this example are placed into the Platinum forwarding class. This assignment occurs regardless of the received CoS bit values in the packet. Apply this filter to the inbound interface. Yep, this all looks really familiar to me as well. Okay. Alright, so moving on. Let's take a look at BA. Maybe if there's BA destination, we can compare it directly. Don't see anything like that. So this has balance in it, so not going to be related to BA, I don't think. Same with this, excess bandwidth, and this as well. So this is everything that's relating to BA. And here we've got something that I learned through my professional experience. We've got 3 different kinds of QoS. QoS that modifies DSCP bits, QoS that modifies IP bits, and QoS that modifies MPLS bits. So depending on the kind of MPLS you enable, it determines the kind of traffic that is prioritized. So if you were to toggle the DSCP bits and expect your traffic from to be routed throughout your network and keep those CoS classifications, you would get things differently than what you expected, because if the packet is going to be routed, if it's at layer 3, you're going to need to modify the bits at layer 3 in order for them to remain consistent throughout their journey. So in that case, you would need to modify the IP bits instead of the DSCP bits. Okay, so let's take a look at all 3, because knowing that distinction is really important. It can be QoS can be really confusing because you get these sorts of charts and tables, but really at its core, we're just talking about a few lines of config like this. One line where we just say, hey, like what do you want? What do you want it marked with? And then applying it to the interface. So, I mean, once you're marking it with, that's where it gets tricky, because you can have it do, just so many millions of things depending on how you mark it. But I don't think it's too difficult conceptually. So the default DSCP classifier shows the forwarding class and packet loss priority (PLP) that are assigned to each well-known DSCP when you apply the explicit default DSCP or DSCP IPv6 classifier. To do this, include the default statement at the edit class of service interfaces, interface-name, unit logical unit number classifiers, DSCP or DSCP IPv6 hierarchy level. Okay, so yeah, this is going to be really good. I won't need to memorize anything like this, because I can just pull it up in my help apropos. Okay, so let's look at the next kind of bits that can be modified by MPLS. Sorry, not by MPLS, by CoS. And this is the Iep Precedence Classifier. So we've got the DSCP classifier and we've got the Iep Precedence Classifier. By default, all logical interfaces are automatically assigned an implicit Iep Precedence Classifier called the Ipprec Compatibility. The Ipprec Compatibility Iep Precedence Classifier maps Iep precedence bits to forwarding classes and loss priorities, as shown in default Iep Precedence Classifier. Okay, so I made an analogy to help me learn QoS before. I don't know if I ever got it on video, but I'd like to try to expand that out. I think that's gonna help. But yeah, so I'm gonna get out my tablet after this and start drawing out my analogy, assuming I actually forgot to charge it. Okay, well, it's at 30% now, battery, so it should be fine. So let's read the last one, and then I'll pull up my tablet and try to explain the analogy I was making, even if I can't put it all together. But before we're doing that, we'll read about the MPLS EXP classifier that is on there by default. For all PICs except PICs mounted on Juniper Networks M-Series multi-service edge router standard non-enhanced FPCs, if you enable the MPLS protocol family on a logical interface, the default MPLS EXP classifier is automatically applied to that logical interface. The default MPLS classifier maps EXP bits to forwarding classes and loss priorities, as shown in default MPLS classifier. Okay, so everything looks great. We get the code points, we get the Iep precedence CoS values, we get the DSCP bits. So we've got everything we need here to write out any sort of policy. So I'm going to explain the analogy that I've been using to think about this, because I have actually put some time into this already. I'm not sure if it was on video or not, but okay, so I'm clicking sketch now. Okay, and I've got a URL, so let's go to that. Okay. Alright, so here's my temporary URL that lasts for an hour. That's all the time I'm going to need. So here's my analogy. If you think of it like a grocery store, so in my neck of the woods we have HEB, but that's perhaps not the best to use, because in this grocery store, which we'll rename to we'll call it CoS Plus is the name of our grocery store. So this grocery store has a kind of unusual set of policies. I don't think actual grocery store will actually have these sets of policies because they're just too complicated. But the first policy is it requires a membership. Okay, and then the second policy is that your membership is on a ranked tier system. So there are employees that can buy a better membership than other employees. So let's say that you can purchase a green membership, a red membership, or a yellow membership. Oops, it's TIERS. Okay, so the membership is required and the membership is sold in tiers. And actually this is not exactly true in the case of MPLS, because there is such thing as just not having a membership and not getting any of the extra perks and bonuses of having a membership. Okay, so let's modify this. We'll say membership required for bonuses, memberships sold in tiers. So when each customer comes to the grocery store, they'll need to interact with so we'll say this is a customer, and they'll need to interact with the doorkeeper, and they'll need to hand them their membership card. So depending on the type of membership card they have, that depends on whether or not they actually get to go into the store or not. So if you have a green membership card, as long as there's room in the store, you're going in the store, you paid for it, you're the exact kind of customer they want, you're in. If you have a yellow membership card, well, as long as all the green people are in, and there's room for more people, you can get in. If we're packed full of green people, sorry, you gotta wait. And then for not having a card at all, you gotta wait until all the yellows and the greens have been served. So this is, I think, a good analogy to learn QoS with. Obviously, there's a lot more complicated than that. There is scheduling. So, I mean, there's all these categories that we're going to learn about. Let's go and pull them up. So there's classification, there's scheduling, there's queuing, there's rewriting, and there's CBF. But I think this is a decent way to think about classification, is just, and let me switch back over. Yep, it's just your membership card. That's classification. So it's required in order to get special treatment. They do let people in without the classification, but they don't get any special treatment. And then it's sold in tiers. People with better memberships get better advantages. And of course, the analogy starts to break down because in an actual scenario like this, the customer would most likely pay more for the advantages of the higher tier of membership and incur some sort of personal deficit for doing so, such as paying more, which does not happen in the actual traffic. If you assign it a higher classification, then it will not be in any way disadvantaged. It will only get advantages. Even like processing power and stuff, because it's just about like, yeah, because when you enable CoS, like basically what you're doing is setting up a lobby area, and then that lobby area is used for extra checks to go into the store. There's a really good analogy too by a network engineer where you can think of CoS like cups. And then you've got a faucet, and I'm not even sure how to so like a faucet would have like a handle on it, and then it would be like over a sink. So like, is that, I don't know, but yeah, I'm gonna have water spilling out. So you can think of, you know, if you have too much traffic, it starts to fill up. So, you know, you need your traffic to flow through. One way you can do that is have all the traffic come out, or you can set up special, you can make your cup special so that only certain kinds of traffic can come out first. So like you have compartments in your cup, and then your cup is filled up in a special way. So this is one way to think of it, but as we go forth, we'll try to think of it using this grocery store customers gaining entry to the store, purchasing items, you know, that sort of thing. We'll try to stick with this one and build that one out. But I actually think this might be enough for classification, the topic of classification. I guess one thing I can do is yeah, so read a little bit more online, maybe even find a example. Okay, and I do need to plug in this tablet like as soon as possible, or else it will run out of batteries. Not. Please use charger that came with device. Okay, my charger is kind of bad, but okay. So yep, that looks good. I don't think I'll need to draw for a while. Let's read this. Yeah, here we go. So behavior aggregate or multi-field classifier, those are our choices. So I would like to ask you about classification methods that are recommended for complex and large-scale networks. It is common practice in QoS implementations to use either BA, behavior aggregate, or MF, multi-field classifier, to identify and separate traffic flows. BA method rely on classifying CoS marking in the network, while MF is based on packet header and allow to classify traffic based on source destination port protocol. Which method is best when comes to Juno's software, hardware, perform romance? Can we assume that MF, okay, well, let's just see the answer. Well, actually, no, this actually, despite the grammar and I get it, a lot of people focusing on technology are learning English as a second language, so I don't really fault the person for this as long as the question is a good question, and it seems like it is, at this point, going to be a good question. The question is, which method is best when it comes to Juno's software hardware performance, behavior aggregate or multi-field classifier? Can we assume that multi-field classifier is more flexible for modern networks but is carrying significant reduction in forwarding capacity because it's using firewall filters? But on the other hand, when we use behavior aggregate only and only trust on application markings, what about the risk that carries? Application administrators that easily modify, is that a security risk in that the CoS bits can be easily modified and the allocated bandwidth can be abused more easily? What is the best approach nowadays if we use BA and MF together in our QoS policy? Where in the network should they be placed? So good question by Powell. A bit of problems there in the language, but I understand that many really deeply technical people are learning English as a second language. Okay, so this looks like a good answer. BA versus MF. The main reason for the popularity of BA is simplicity. Typically inside the network you create, for example, a core BA classifier and you replicate it across the network facing ports, and that's it. Nice, very simple and very easy to maintain. Okay, so it sounds like this is kind of like a difference between LDP and RSVP, where LDP is simple and automatic, and RSVP requires more complex configuration, but you get more features from it. So it's kind of like the difference between a stick shift car and a manual shift car. Stick shift car, you can switch gears at will, you have more control over what the car actually does, but an automatic car runs without you having to run it correctly. MF is more flexible indeed, but sometimes that flexible carries additional burden. For example, if TCP destination port X is to be mapped to the class of services Z, then you also need to define rules for what is not TCP, or what is TCP but not destination port X. However, sometimes you do need to look at the packet header since the packet marking is not enough. For example, VoIP devices that send all traffic with the same marking, and you want to separate between control and data. That's an example where packet marking is not enough. It is not easy for large-scale deployments to manage per customer firewall filters. Now, coming to your last point about when you don't trust the packet CoS markings, then indeed BA is not an option. It needs to be done using MF, but it can get more interesting since if you don't trust the markings, can you trust the header? Before expanding on that, let me lay down the typical scenario at core-facing ports, any port that doesn't face a CPE. Typically, what is used is BA. Packets are inside the trust zone. Look at the packet marking and map to a class of service. When packets enter the network from the CPE, you cannot trust the markings. Then just use rewrite rules in the egress from the device where they are received to the next network device that will receive them. At customer-facing ports, it gets more interesting. You can use BA or use a combination of BA and MF or just MF for customer-facing ports. MF is applied. Yeah, and I remember there being a big difference between the QoS applied at customer ports and the QoS applied at core ports. At customer-facing ports, it gets more interesting. You can use BA or a combination of BA and MF or just MF. MF is applied after BA, so you can do the first round of classification using BA and then fine-tune with MF when required. For example, DSCP-A, CoS1 applied using BA, DSCP-B, CoS2 applied using BA, DSCP-B plus TCP port X, CoS3, all others don't touch it. Packet arriving with that DSCP-B and that header are assigned to CoS3. For all others, CoS assignment is untouched, meaning BA output is not changed. Now back to trust borders. So you cannot trust the traffic markings and headers you receive. There are several sub-scenarios. Number one, only one class of service contracted. Then it is easy. MF filter with just then CoSA. Several classes of traffic contracted. Then I can assume there is a rate per CoS contracted. If so, MF is the way, just one term per CoS with a policer attached to it. At large-scale deployments, typically what happens is that several classes of service are available, and depending on what is contracted, the network customer is instructed of what are the .1p or DSCP markings that CPE needs to use when sending traffic into the network, and that if enforced via policing at ingress. But then keep in mind that the packet markings can still be wrong, so don't forget to rewrite them before sending the traffic upstream, so that the next network device is not fooled by wrong packet markings. This is critical. When a packet enters the network, its markings should always be trustable. Okay, so yeah, that looks good to me. Glad I read that. Let's see if we can find a Juniper example for classification. Okay, so this looks good to me. Classifying all traffic from a remote device by configuring fixed interface-based classification. And this is from the Class of Service Users Guide for routers and switches. Okay, and it looks like we do have an MF classifier. Do we have a BA classifier? And what do MF and BA stand for again? I forget. Let's try to find the Juniper Class of Service feature guide. That's a user guide. I want the feature guide. Alright, so I don't see a different feature guide. I think this is going to be the main one. That's totally fine. Let's see if there's anything in this about BA classifiers. Ah, here we go. So we've got configuring BA classifiers and applying a BA classifier to an interface. Looks like we've got at least 7 more results here. Okay, but those 2 results look good, so now let's look for MF classifiers. So here we go. Configuring a firewall filter for an MF classifier on customer interfaces. Alright, so I think these are the 4 sources we're going to focus on for the next half hour or so. This doesn't need to be a super long video. I don't need to spend, hours and hours on every single topic. I think classification is a pretty simple concept. I'm going to try to do it myself without looking at these, and then we'll see how close that is to what actually is in these examples. So if I were to just think to myself about what classification would require as far as the configuration is concerned, I would go on to router 2. I'd go edit firewall, and then I would do edit filter, because that's basically what classification is serving as, is a filter in some sense. I am curious what's under family. Okay, but so family is just more filtering. Let's go under filter. Yep, and now we're going to say classification. Okay, so here's where you can determine what you want to classify. So let's do term 1 from. And now we can classify our traffic based on any number of things, based on the IP precedence, which will be useful for traffic on layer 3, based on the DSCP values, which will be useful, so differentiated services code points, which will be useful for traffic on layer 2, and based on MPLS, which will be useful if we are looking at MPLS labels and not either frame headers or packet headers. But unfortunately, it looks like classifying it based on MPLS is not listed here. Maybe it's in a different section of the configuration or something like that, but that unfortunately looks like it's not going to be an option. Let's set up and classify it based on the ICMP code, just so we can have testing be more simple. Okay, so now we're going to need to give it which code to classify it on. So we've got all sorts of different kinds of codes, port unreachable, network unreachable, IP header bad. I guess what I was looking for is a code that I could manually set when deciding to ping the other side, and then have this match. So we do have a range of values, whatever that means. Maybe we could classify it based on the TCP flags and then set to different kinds of... No, that won't work either. Yeah, I think IP precedence is what I'm thinking of, because that's when we can actually set bits. So yeah, I think this is pretty easy. Set from one, set term 1 from precedence. Okay, and then here's the and then we're going to do internet protocol. Yeah. and then set term 1 then, and then we can decide what we want to do with it. Let's just go with reject for now. Okay, so there you go, nice and easy. So now let's see if I can set precedence bits when I ping something. So let's do ping 10.1.1.1. We've got no IP addresses yet, so it's not going to actually ping anything, but I just want to see if I can set CoS bits, anything like that, in my ping. Perhaps in a hexadecimal fill pattern. Does that make sense? Okay, here we go. So I think this is where I do it, in the TOS. I think. I have no idea. Okay, so let's try that. We're gonna pin up an IP between the two, and we'll try pinging from one to the other, and we should see the traffic go through without a TOS value, but the traffic rejected when the TOS value matches the value that we set up in our policy, in our firewall filter. So it's going to be the internet control value, whichever value that is. Hopefully we can figure that out with a help apropos. Nope. Perfect, so it looks good to me. We've got pings going. So let's try setting the TOS value, IP type of service value. I'm not sure, so that seems quite a bit different than the precedence. I'm not sure if the TOS is the same as the precedence. I don't believe it is. It's the type of service, and the precedence is the precedence. Firewall filter classification term 1. Possibly set relative. So I'm going to see if perhaps they have TOS I can match on. Nope. Lost priority. Can I set that? Huh. Oh, let's say that if the do not fragment bit is set, then we'll get rid of it. Oh my god, what are the fragment flags? Okay, so let's see how the fragment flag's different. We'll use Wireshark for that. Okay, so here's without do not fragment. And we're not getting the traffic showing up in Wireshark for some reason. We are pinging from router 1 to router 2, so there's no reason for it not to show up unless I'm pinging myself by accident. Okay, so there's some sort of issue here. Okay, so let's just try the classic, shut it down and restart it. There we go, that looks a lot better. So now let's see what it looks like with the do not fragment. Okay, so that's going to be enough. We can stop the capture now. Okay, so this first one here is going to be without that bit. So if we go under the here and then we look at the flags, so we can see that the reserve bit is not set. Let's switch this over to hexadecimal so we can see exactly how it looks. So we can see how it needs to be entered. Okay, so it looks like it's going to be 0000. Let's see how it looks here. Okay, so here it would be 4000. So there's a difference between 0000 and 4000. So let's say that if it's 4000, we're going to toss it out. Then reject. So the then reject statement is looking good so far. We will need to clean up that other statement that is there. Okay, so now our policy should throw away the packets that were what? Why did it fail? Configuration checkoff failed. Huh. Oh, you know what? I think I've got to tell it what kind of fragment flags am I checking? Like, where are these fragment flags that I need to check? So I'm going to need 2 edit statements, I think. Yeah, so it's going to be TCP flags. Oh. Oh wait, no, it's actually going to be, yeah, I think this is going to be right because the flag for the actual fragment is just a 1 or a 0. So we can do it that way. Let's actually do it that way. That might be a little bit simpler. Okay, so we won't need to modify the TCP flags. There we go. Okay, so, but now we can change the fragment flags to 400. I think it wasn't accepted because, as we see in our Wireshark capture, there aren't 4 digits in a hexadecimal representation of fragment flags. There is actually only 1 digit. We can see it's the first digit here. Sorry, no, it's the second digit here, I believe. Well, I'm not sure if it's the only the second digit or if it's both of these. So I actually am in fact going to use the other one, the TCP flags instead of the fragment flags. I just think that'll be a lot easier. Yeah, so let's set term 1 from TCP flags 400, and then we've already got the then reject statement. Okay, so we should have. Oh. Huh, okay, so it looks like I can't get any extra information. I'm not sure why it's so, why it's having so much trouble. I mean, I guess I would think it's because my syntax here is not correct. But the syntax seems to be correct for flags, at least according to Wireshark. Maybe I need 0x. Oh, okay. So yeah, it only required 2, so the syntax was all off. Hopefully things work now. Okay, so let's make sure it still works without that. Okay, and now here's the big moment of truth, and it still works even. Okay, well, god damn it. Okay. Oh, god damn it. Oh, that really sucks. God damn it. Jesus. Yeah, I mean, it's going to be a 4 because we've got 1, 2, 4. So this, it's not that the bit is going to be 1, because this is the 4's place in the octet. So it would be 4, 0. But obviously, oh, you know what? God damn it. I never applied the policy. I've got to apply it to the interface. So let's do that. Ah. Okay, so now that the policy is applied, it doesn't work. Aha! So it needed to be applied under family INET. I think if it were applied not under family INET, it would have to be a policy containing DSCP or modifying DSCP. But DSCP, Differentiated Services Code Point. So we've got a little bit different results here. It's not able to ping, but it's not exactly working the way I thought it would. I'm not able to ping when I don't have the TCP flags marked as 4.0. Oh, and you know what? I think that's because I don't have an allow statement. So let's do configure private, and then we'll do term 2, then accept. Perfect. So now it'll accept everything else. There is an implicit deny in Juniper, just like there is in Cisco. So just because it didn't match this doesn't mean that it was allowed. It actually means that it was rejected by default. Okay, so now our ping is working where we don't set the do not fragment flag. And the one where, god damn. Oh my god. You know what? Paper towels are pretty safe, I think. There's a garage underneath me. There's no other apartment. There's just a garage with cars underneath me. So I'm doing that. All right. So I don't know why this didn't work. I thought it was going to work, but it didn't work. Yeah, if it had TCP flags 4.0, it would reject it. But then maybe I overwrote term 1. Maybe I accidentally said term 1 instead of term 2. No, I said term 2 and I got the same name right. So yeah, if it matches this, it should reject it. But if it doesn't match that, it should accept it, right? And then this one here should, we saw in the Wireshark capture, will match it, but this one here will not match it, and we'll get that term 2 and be accepted. But this one, I was expecting to hit the term 1 and be rejected. Clearly that is not the case though, and I don't know why that's not the case, and it's really frustrating that I don't know why it's not the case, because I'm going to literally take a test on this in 3 weeks. Oh, you know what? No, because we saw it was working. I was thinking like maybe it's not applied under the right area of the interface. But now it's got to be family. Is it maybe the wrong? Maybe it needs to be. I mean, we could try that. We could try toggling, changing it to be output instead of input. Alright, and I better put my paper towels back on the desk in case I spill something. Okay, so alright, yeah, so now let's see if there's a difference. See if it still works when we don't fragment. It does. But yeah, I mean that it will need to be input. So yeah, I guess I'm really confused. Oh yeah. You know what? I kind of got a little bit distracted. Let's see what the actual examples have me do. Okay, so they're using DESC. Okay, so hopefully the example will make everything nice and clear. Perfect, and it looks like the example has 3 routers, just like I have. They're going to walk me through it really nice and easy. So it looks like I just need one more host. Okay, and yeah, so let's do this full example, and then that will be the end of this topic. So this is classifying all traffic from a remote device by configuring fixed interface-based classification. This example shows the configuration of fixed classification based on the incoming interface. Fixed classification can be based on the physical interface, such as in ATM or gigabit Ethernet interface, or a logical interface, such as an Ethernet VLAN, a frame relay DLCI, or an MPLS tunnel. Requirements to verify this procedure. This example uses a traffic generator. The traffic generator can be hardware-based, or it can be software running on a server or host machine. The functionality in this procedure is widely supported on devices that run Junos OS. The example shown here was tested and verified on SRX series devices running Junos OS release 12.1. The SRX devices are configured to run as routers. If you are performing tests on SRX devices, you might need to configure the devices to run as unsecured routers in your test environments. You would not typically do this in a production environment. Overview: a fixed interface classifier is the simplest way to classify all packets from a specific interface to a forwarding class. This is typically used on edge routers to classify all traffic from a remote router or server to a certain forwarding class and queue. A fixed interface classifier simply looks at the ingress interface on which the packet arrives and assigns all traffic received on that interface to a certain class of traffic. The fixed interface classifier cannot set the locally meaningful packet loss priority, which is used by rewrite rules and drop profiles. The implicit packet loss priority is low for all fixed interface classifiers. A fixed interface classifier is inadequate for scenarios in which interfaces receive traffic that belongs to multiple classes of traffic. However, the interface-based classification can be useful when it is combined with other classification processes. Filtering based on the inbound interface can improve the granularity of classification. For example, when combined with filtering based on code point markings. Combining the processes for interface and code point marking classification allows a single code point marking to have different meanings depending on the interface on which the packet is received. If you want to combine a fixed interface classifier with a code point classifier, this is in effect a multi-field classifier. More granular alternative to fixed interface classifier. In Junos OS, you can combine interface-based classification and code point classification by using a multi-field classifier as follows. So here we have both DSCP-EF as the from, and we have the actual interface. So we're combining interface-based classification. We're including this command here, and we're combining, and that is alongside code point classification, differentiated services code point classification in this line here. Classifiers are described in more detail in the following Junos Networks Learning Byte video. 15 minutes isn't so bad, let's watch the whole thing at double speed.
Certification program in education services here at Juniper. This was provided in the classes for basic series and focus on classification. So here's our master page, laying out the main components of why we use this device, and we'll work with this by using the first one, classification. So when traffic comes into your device, you want to separate it out so you can treat it differently. You use traffic prioritization or other traffic. And the way you do this is using classifiers on the device. So classifiers just separate that traffic, so you treat it differently as you get further into the CoS process. Now, before classes are just physical queues in the device, you might get the idea of incoming traffic queues or queues. Well, let's effectively the same thing. When we talk in terms of configuration, you need to think of four classes, but they are together. So you can see the diagram below there, coming into the device, hitting the classifier, and based on the right criteria, just coming up, split into different classes of queues. Now, classifiers also have an additional layer of traffic separation called loss priority, or progress, if you like. There's later on process like servers, schedulers, another layer, as I said, to mark traffic within a forwarding class and mark it differently for a high level drop priority or low level as you get further along. It helps you get more granular control to make decisions about drop traffic congestion. In terms of configuring forwarding classes, this device comes with 4 default classes already set up. They are separate, expedited forwarding, assured forwarding, and network control. Now, these are standardized traffic classes. We can discuss these in the first overview learning by classes or basis, but I strongly encourage you to check out additional resources to learn about these standards, the terminology, the costs, the settings that go with each of those classes. So again, I encourage you to get more familiar with each of those because you're sure to see them in next. But you can configure your own here, and some examples on the right side. Now, depending on the device that you're working on, you might configure either the first or second method, but they essentially use the same result. You can see here in the class service section of the configuration hierarchy, there's a forwarding classes section. And in each case, what you're able to do are two things. The first is to name your different forwarding classes and create them as well. And then you're also going to associate classes with the queue. So as you see there, we created 4 new forwarding classes as an example, and each one is associated with queue 0 through 3. Now, what I want to note here is that the numbers for queue classes can vary a little bit depending on the platform you're using, some higher capacity than others. So I encourage you to check the technical documentation for your particular product and find out how many queue classes you can work with on your device. There are 2 general mechanisms that are available in device classification, and this slide discusses the first one. It's called multi-field classification. You can separate out the traffic based on a variety of parameters in the packet headers. So think about an packet header, things like IP addressing or port values, any of those kinds of parameters can be used here. Now, the implementation of it on each device is to configure multi-field classification using a firewall filter, and that's what allows us to get that granular control based on what the packet header reveals. It's a two-step process. You configure a firewall filter to separate and hash traffic as you want to do the classes, and then once you apply ISO somewhere, so you'll apply it to the appropriate interface where you want that traffic to get, as an example. So you can see examples of configuration elements at the bottom there. So on the left, we find a filter. We are in the firewall section here. You can see a filter called N classifier there. It has a term that matches against a particular source address subnet 1.1.1/24. And you can see the result in that statement. It assigns traffic that matches that parameter into a forwarding class called premium data. So we have a mechanism here to classify incoming traffic from a particular element of the network. We then apply that to the relative place where traffic is expected to come to our device. And since you see on the right side, we can apply our MF classifier filter as an input filter on that particular interface. The second option, classification, is called Iep aggregate classification. Now, this type of classification is used when the traffic on your device already has constant markings in the header. You can make use of these markings, and instead of looking for various other packet fields, use these markings directly, assign it to you, assign traffic to you, and send it on its way for cost processing. Things like configured in the class service section hierarchy. So on the left side there, you can see a classifier. This one, it's of type DSCP, so that's an IP4 disk or floating point classifier. We're going to go to the IP4 head space called IP4A classifier. And there are extensive here about this classifier. Now, probably the easiest way to interpret this is you can read it backwards. So if I take the bottom example there, and read it from right to left backwards, so that local point of 101.111 will traffic coming in that has no bits in the CoS header, or the CoS by the packet header, will be given a loss priority set below and assigned to a forwarding class new data. So if you use that approach, you follow all the way up to the example there, to the top, so no bits at all, zeros, well, that belongs in the desktop data forwarding class, so they loss priority set high. So that's the mechanism that's used to define classifier. And you can carry on and find more forwarding classes as you use classifier, and you can also find levels of loss priority. So you can very customized that kind of thing. On the right side, you can see applying this classifier. We're still in the class service section, and for the appropriate interface, we are applying the classifier again, DSCP, so IP4 classifier here, and we label the classifier again to apply. And so let's do the demo portion here. I'm going to show some examples in action. You're going to configure your forwarding classes, and then we'll try to locate the classifier. Now you can see our diagram there. We're going to go from a traffic generation server sends traffic across our relay network. And so the relevant interface there, now you can see an classifier on G06, and then we'll also counter as traffic is on G0 as well. Okay, so the first thing I'll show you is those default forwarding classes that are actually on the device by default. Let's just pull those up. There you go, you can see those 4. That's expedited forwarding, assured forwarding, and network control, all assigned to their default queues and in place here. So now let's go into our relevant configurator, check out a couple things that I pre-configured here on the device already. So the first thing is, we want to customize forwarding classes. And you can see the example I've done there, built a forwarding class standard and assign our 4 custom forwarding classes and assign them to like queues here. So I'm just going to activate this on the device. There we go, that's good to go. The next thing we're going to do is look at a multi-field classifier. I have pre-configured one here as well. And you can see our firewall examples I've created called MF classifier, and it has 2 terms. We're matching on a term called data, and it's going to match TCP traffic at port 80, and for traffic that matches that, we're going to send it and assign the forwarding class, the data. Next term there, called premium data, we're going to match on TCP traffic at port 12345, and that traffic is going to be assigned to the forwarding class premium data. So it's all over your device, so I'm going to activate it. So it's like this now. Now remember that firewall filters are fine to go. You can read those much like they do many things to apply that somewhere. So I'm going to apply this to our incoming or our ingress interface.
Oh, is that what? But how is it? Is it because I didn't activate the filter? Oh, No. Okay, yeah. I was supposed to be like, what? I'm not going to remember that on the test. That's ridiculous.
G066. And we call our filter there. There it is. So just show up G06 everything is good. So we're going to do this. Okay, it's good. I'm just going to some interfaces here to make sure things are easier to see as you are monitoring this traffic. Now I'm going to switch over to a traffic generator. Here, I'm using a tool called HChain. It gives us the ability to send traffic onto the ports. So I'm sending to a IP address further along the network, just pops down. I'm sending out 50 packets. It's going to do it quickly here, and I'm going to use port 80 TCP. Here it goes. There's our packet all set up. Now I'm going to switch over here and check out our status on the egress interface. So that's important. Let's see what's important here. When you want to look at the result of processing, including things like assigning traffic to queues or classes, well, one of the mechanics of that are actually done around things around things like assigning bandwidth to queues, giving traffic classes on phosphorus space, things of that nature. And those things actually happen on the egress side of the device. And so that's to say, we monitor these things and see traffic go by. Well, we look on the egress side of the device where traffic is going. Now you can see right here, we've got our customized queues. And you can see queue transaction nodes, our customized queues, and you can see other packets went through that Q0 and EDA core classes, just like assigned to the out of field filter. And classify. 51 packets are called packets going around, so 51 copies of packets. All right, let's switch back, and let's try and send traffic to port 1245. So same general gate command here, we'll try that. Here we go. Let's go right back here and check our interface status here. Using the CSS command provides a huge amount of information, including relevant IP addresses here. You can see under 2 counters, there are 41 classes again that are used, and now you can see exactly 50 packets that's sent through, and matches on that 41 class multi-gate classifier, and the other traffic assigned to the median data 41 class. So that's the end of this device. Constantly huge traffic. There's more detail we can get into here, so I encourage you to get a number of devices for information. The first is check out documentation for your device. As I mentioned earlier, there are new variations. There are other processes. If you want to check out the variations to ensure that you have, you understand the number 41 classes used available for your device, and when there's all options, find details of features for your interface device. The next one, let's get more information about cost general. Is our next cost space looking at. Next one, we'll move on to the next stage major, cost stages that are light here, and then we'll look at those. There's also formalized education service training. Juniper Essentials has some coverage on costs, as does the full day Juniper Classic service. Lots of depth and training there. As I mentioned already, documentation, check your diagrams, what's specific product, and also data diagrams as well, called basic CoS, good hand for documenting like to remove cost loss from an example case study perspective. Thanks for listening, and catch you next time. Bye now.
Visit the Juniper Education Services website to learn more about courses. You want full range classes, online, and e-learning courses.
Okay, so I didn't pay super well attention to that. I started reading a new book I bought in the middle of that. So, yeah, and that was when he was describing, kind of what you need to know, and just what a mountain of a giant topic it is. But let's say that we're good as far as classification is going, as long as we get through this example here. So this is a fixed interface classifier scenario to simulate voice traffic. This example uses TCP packets. Oh, and I'll arrange my lab so it's more similar. There we go. Sent from the host to a downstream device. On device R2, a fixed interface classifier routes the packets into the queue defined for voice traffic. The classifier is assigned to interface GE000. Oops, and it looks like they have different wiring than I do, so I'll just, since they're using the same interface naming, I'll use the same wiring they have. Alright, so it's going to be from the host to the router on GE1, then GE1-to-1 between routers. Oh, no, sorry. Wait, I did that all wrong. My brain glitched. Okay, so it's going to be 0 to 1, and then it's going to be 0 to 0, and then 1 to 1. Okay, and I'll turn on the Cisco. Alright, that's good to me. So, Yeah. So as always, verification of assignment queue is done on the egress interface, which is GE001 on device R2, this one here. Okay, so let's get started with R1. And I'll just blank it out before I get started again. Right, everything looks good on router 1. Time to configure router 2. And it looks like router 2 is actually going to have the classifier on it. Oops. Okay, so that looks good to me. Don't need to do the step-by-step unless there's anything particularly interesting, but I don't see anything super interesting popping out. So let's skip down to the verification steps. So we're going to be verifying that the fixed interface classifier is enabled on device R2's ingress interface. Keep in mind that although the classifier operates on incoming packets, you view the resulting queue assignment on the outgoing interface. And that makes sense because if we think back to our grocery store, well, here's where the grocery store analogy is kind of gets a little bit tricky, because it's better to think of it as the person in the lobby area sees customers coming in, and instead of the customer presenting the card to the person in the lobby area, the person in the lobby area presents the card to the customer. And then when the customer leaves, they still have that card. That's a better way to think of it. It's really not how most grocery stores would work, but it's how CoS works. And that's why you've got to check it on the outgoing. You can't check it on the ingoing because the customer doesn't have the card yet. The store recognizes the customer and hands them the appropriate card. And then your classification rules are not things that are given to the customers, they're things that are given to the attendant at the store. All customers wearing glasses get a special card that allows them to skip the checkout line and get a special treatment. And then after they've left the store, they have that card they were given that tells them the treatment they're getting. So when they go to a different store, now you can not only classify the customer based on are they wearing glasses, are they wearing a blue shirt, do they have a card that they received from the other store. Alright, so let's go to router 2. Okay, so now let's use a packet generator from the hosts. So hping 3. I guess I'm not sure what HP ping 3 is. I'm hoping just regular pings will be enough, but we'll see about that. We are going to need a IP address on GE001 on router 1, and as well as a IP address on the Cisco. Oh, so right now I'm on router 1, so we'll need to open up the Cisco as well, which is router 4. Okay, so let's see if we can ping all the way to that address now. Okay, so it looks like there's some problems. Okay, well let me think here. Is this... Yeah, that's set up right. Can I ping to the other side? Can ping to the side. Oh, you know what? I don't think I configured this last router yet. Oh, no, I did configure the last router. Let's see here. Oh, but that's router 3, not router 4. Oh, no, it is meant to be router 3. Yeah, so it looks good. Huh. Maybe I'm not using the same. Nope, it's router 1, router 2, router 3. Huh. Oh, no, here's my problem. I did a .1 here instead of a .2. Okay, let's see if this works. Okay, so maybe I got the other side wrong as well. That's interesting. Can I ping? Let's try a trace route. Huh, we can't even get across the wire. Oh, of course, because I don't have a route. Yeah, I think I need a route. So let's just set up a static route. And I believe it's .2. I guess I'm not sure. It'd be nice if I could check. Nope, it's going to be. Yep, no, it is going to be .2 because it's for the next hop. Alright, so now I should be able to ping. I just needed that static route. I didn't have a route to. Yeah, perfect. Okay. So, yeah, so let's see the verification steps. Okay, so we'll let it run with 10,000, and then we'll go to router 2. We'll do show interface extensive 1 find counters pattern not found QUECOUNTERS. Do I need that 0? No. Oh, you know what? It's probably a capital. Huh. What the heck? I'm so confused. I'm really confused right now. Huh. I'm so confused. Why do I not get like Q counters or anything like that? Oh, here we go. Whoa! Oh, it's my cron job. Okay, yeah, my cron job is 11:30 every day. So, okay, I'm sure it was incremented. I've just got different queue counters than they got. I think this is a decent area to stop. Let me do one thing before I stop the video, and I'm gonna make it a little bit more clear how my grocery store shopping analogy is a bit flawed. Oops, so it looks like my sketch pad expired. I only get an hour on it. So I will create a new one. Alright, and then I will explain how my grocery store analogy was a little bit flawed and can be better. So it used to be that customers would carry special tickets with them, and then that ticket would say give them special privileges, but a more accurate way to say is that in the store, which we're calling CoS Plus, we have a special lobby area, and then we have the actual door to the store, and the customers all line up to go into the lobby area. But some are different in some ways. Some wear glasses, some don't wear glasses. So let's say that there are customers that wear glasses, and then there are customers that don't wear glasses, so they all come in. So depending on whether or not the customer wears glasses or not, this customer does wear glasses, the greeter at the store will hand them a card, and this card will tell them as they're in here the special privileges they get depending on whether they are or are not wearing glasses. So then when they leave the store, there will be customers out and about that have these cards or don't have these cards, and in this case it will be classified based on whether or not they're wearing glasses. but you can also in the future in a different store make decisions on whether or not they received cards from the first store. So CoS is very complicated, very in-depth topic. It's unfortunately gets really quite in the weeds fast. I think at an overall viewpoint from afar, it's not super complicated, but there's just so many different details and variations that it gets complicated very fast. But I think this is all I'm going to do for the classification topic. So thanks for watching, and I'll see you in the next one where I move on to scheduling.